beautiful people, and welcome to the Chem Lab. At some point in your chemistry travels, you're going to be asked questions about chemical and physical changes. As you work your way through your chemistry lab sequence, you're going to see a lot of changes. And our first job as chemists is to be able to make sense of those changes and ask ourselves, is what we're seeing a chemical change or a physical change? So in this video, we're going to talk about the definitions of both of those. We're going to look at some examples of both of those, and we're going to finally look at a small number of questions that you might see on an exam. So let's get into it. So what is the difference between a physical change and a chemical change? Really, there is one really big difference in the definitions, and here they are. So a physical change is a change in which no new substance is created. So there are changes that happen, and sometimes they look like things are changing and making something new. But if you're seeing a change where nothing new is being made, no new molecules, no new chemicals, then that is a physical change. A chemical change is a change that actually produces a new substance that wasn't there before. And so that's really the criteria. Am I making something new or am I not making something new? And so we're going to look at some examples of that. Sometimes it's hard to tell, but I'm going to give you a little list for each one. Let's start with the physical changes. These are some examples. This is not a complete list, but these are very common that you'll see. Examples of physical changes: melting, or for the opposite of that, freezing. And you might be thinking to yourself, well, wait a minute, wait. If I melt some ice, that's definitely changing. It's making water that wasn't there before, right? And you have to think to yourself, okay, are the molecules themselves changing, or are they simply changing the way they're arranged? And when you're melting and freezing something, you're not actually making any new molecules. You're just, for example, in melting, freeing them up from each other so they can flow in the liquid state, but they can be turned back into the solid state pretty easily and with no changes at all. So melting and freezing, that can be a tricky one for beginning chemists. Boiling, condensing, sublimating, and depositing, same ideas. I can boil water, I can get the water back and condense it. And so I still have water and I haven't made anything new. Sublimation, if you're not sure, is actually when something goes from a solid directly to the gas phase without being a liquid in the middle. Dry ice does that, among other things. And depositing is the opposite of that. Depositing is kind of what happens on a cold winter night when frost forms on your windshield, and it wasn't liquid there before, but just kind of dropped out of the air to deposit. Evaporating, again, a similar kind of thing. You might be boiling something, and it looks like it's going away, and it's turning into steam. It's still the same molecules, so you got to have that. Dissolving. This is a tricky one for a lot of people at the beginning because they see the stuff going in, and it disappears, and it's not there anymore. And we've made a solution that wasn't there before either. And so people sometimes erroneously think that that is a chemical change, but in fact, it's actually just physical. You're just mixing ions or molecules in with the solvent that you're using. Changes in shape, whether you're hammering something with a hammer and denting it, or crushing it into smaller pieces. That if something is brittle, it would do that. Both of those are just changing in shape. You still have the same molecules. And mixing things. Like if I mix some sand and some salt, I still get the grains of both of those. I'm just happen to be mixing them together. I haven't made anything new out of that. So those are some examples of physical changes that you might see in questions. And let's talk about chemical changes. Some examples of chemical changes. These are all words and examples that describe chemical reactions. What might happen in a chemical reaction? First of all, the formation of a precipitate would be a chemical change because you're taking two solutions in which the solutes are dissolved, and when you mix them, they undissolve and they produce something that wasn't there before. Usually it has a color, sometimes it's white, sometimes it's something else that's more exciting, but precipitate. If you're going along and you see a gas that is being formed spontaneously, that is generally a result of a chemical change. That gas wasn't there before. And you have to be careful sometimes because sometimes when things are boiling, it looks like they're producing gas in there. But in fact, they're just turning into vapor. Burning of a fuel and oxygen. Every time you see some fire going on, chemical change, awesome. Rusting, oxidation of something when something tarnishes. Those are kind of related terms. But yeah, when you start to see like an oxide coating or something like that, the formation of water in an acid-base neutralization. I included that one in there because sometimes it's harder to see. You might be mixing a clear solution with the clear solution, and you might not notice the water that's actually being formed. What you might notice, though, is that energy is spontaneously absorbed or released in a chemical reaction. And so that's usually a tip off that a reaction's happening. I also included my favorite type of chemical reaction, the browning of food, which is an endothermic reaction where you put in energy and your food browns or it cooks or it does something so you can eat it. So that's one of my favorites. And now let's look at some questions that you might see. These are like AP level questions, though if you're in an introductory chemistry course, you might see something similar to this. And we'll do a couple of them, and I have a pause the video one for you if you've been paying attention. A student was asked to formulate a hypothesis about what would happen if 100 milliliters of 0.1 molar NaOH at 25 degrees Celsius was combined with 100 milliliters of 0.1 molar magnesium chloride at 25. Which of the following hypotheses indicates that the student thought a chemical change would occur? Okay, so we're looking for evidence of a chemical change or a hypothesis of a chemical change. The volumes of the solution will be equal to the sum of the volumes of the original solution. Not a chemical change, we're just mixing, and the volumes would theoretically add up to the total. The mass of the resulting solution will be equal to the sum of the masses of the original solution. Yes, the law of conservation of mass exists, and it says that in chemical reactions, no mass is created or destroyed. But again, that's just, we're just taking masses and adding them up. The resulting solution would contain a precipitate. Wait, that was one of my choices on evidence for a chemical change. And let's just check letter D. The resulting solution will be clear. That may or may not indicate anything. So our correct answer here is letter C on that. All right, next question. This will be a quick one. A student was studying physical and chemical changes. The student carried out some procedures in the laboratory and recorded observations. For one of the procedures, the student concluded that the physical change took place, but not a chemical change. So which of the following could have been the results of the procedure? So now we're looking for a physical change, one that does not create anything new. A cube of metal was changed into a flat sheet of metal. Okay, I think we might have our answer right off the bat there, because just changing the shape of something doesn't necessarily change the molecules making it up. When two liquids at room temperature were combined in a beaker, the beaker became hot. Okay, that's spontaneous production of heat. That indicates usually a chemical change, not a physical change. When two clear liquids are combined, the resulting mixture was cloudy. That's kind of like a precipitate. That's on our list of chemical changes. And when a colorless liquid is added to a blue liquid, the resulting solution was yellow. So color changes. Okay, so we have a color change, which you might think is just a physical change, right? We're just changing the color. But usually the change in color is accompanied by a chemical change, or it signals a chemical change. So the only one here that's a true physical change is letter A. Just hammering out a cube of metal into a sheet, that's just not changing the metal. And now here's a pause the video moment for you if you paid attention during our notes section. We have an acid-base reaction, hydrochloric plus sodium hydroxide making this and this. A student had two dilute colorless solutions, hydrochloric and NaOH, which were at the same temperature. The student combined the solutions and the reaction represented above occurred. Which of the following results would be evidence that a chemical reaction took place? Take a moment, pause the video, and I'll see you back here in a couple seconds. And if you paid attention a few minutes ago and noticed that the temperature of the reaction mixture increases, and that's a spontaneous release of energy, that indicates a chemical change. So good job on picking that up. So chemical physical changes often are at the very beginning of a chemistry course. In the AP chemistry course, they included at the beginning of Unit 4, which is on chemical reactions. And I guess that makes sense because we are looking at a whole chapter or unit on chemical reactions, and we have to be able to tell them apart from physical changes. And so it's included in section 4.1. I hope you found this helpful. If you have any questions, send them to me in the comments. And in the meantime, happy studying and have a great day.